Hello everyone, let me check if the stream started or not. Then I can start the class. Just give me a moment, please. Yeah. So class started. Hello Lohi, hello. So as discussed, so if you are following our channel, Monday's class was cut short because of the power failure in our studio. So we could not complete the class. So that class will be completed on coming Monday. Okay, we will complete that class itself, and then we will continue with the next part, right? So that is one important thing. So today we are basically going to do quiz for the chapter electric charges and field. Quiz means the questions, some of the questions we are going to practice from the chapters electric charges and field. This chapter is entirely completed, so if you have any basically it will be a practice for you. So all the questions, all the important questions that you want to practice, that is here in our session today. So let's start. So first question, so we will be solving questions one by one. All the questions are important, so do not ignore it, and they are not covered in our PYQ session. Some of the questions are PYQ, some of the questions are not from the PYQ. So but yes, all the questions are basically important. A point charge A of charge plus 4 microcoulomb, let me change the pen, 0.4 microcoulomb, and another point charge B of charge minus 1 microcoulomb are placed in air at a distance 1 meter apart. Then the distance of the point on the line joining the charges are from the charge B, where is the resultant electric field is 0 in meters. So 2 point charges are here. Okay, one is at A, one is at B. Okay, plus 4 microcoulomb and minus 1 microcoulomb. Now it says that distance between them is 1 meter. So 1 meter is the distance, and it is said that then the distance of the point on the line joining the charges and from the charge B. So who is charge B? Charge B is minus 1 microcoulomb. Very important to note. So charge B is minus 1 microcoulomb. So from this charge, what should be the distance where the electric field is 0? Right? Obviously it should be a fraction. Now if you are considering inside the point, it can be 0 here as well. Okay, so first of all we have to find out whether it will be between these two charges or it will be beyond these charges. That is very important point to understand. So this charge is positive, this charge is negative. So if you consider a point between these two points, okay, if you consider a point between these 2 points A and B, what will be the electric field due to A? Electric field due to A will be away. For positive charge, electric field is always away from. So this is the electric field due to A. What will be the electric field due to B? B is the negative charge. So negative charge, electric field is always towards. That means the electric field due to B will be towards the negative charge. So in no condition there will be a null point or a 0 electric field between these two charges. Very important point to remember. If charges symbols are opposite, so one charge is positive, one charge is negative, then you will not be able to get a charge where just a second, you will not be able to get a charge which is basically just give me a second. Okay, so you will not be able to get a charge where null point is between the charges. That is very important point to remember. So if both charges are positive, then you might get a null point in the in between point, or if both charges are negative. But if one charge is positive, like this given here, one charge is positive, one charge is negative, you will never get a null point between the charges. So electric field can never be 0 between A and B, so it has to be on this side. It has to be on this side or this side. Okay, anywhere it can be. So let's say that the point is on this side, say at a distance x. At a distance x from -1, we have the null point, and we are trying to find the null point based on this. Okay, so what will be the electric field due to this? Now here the electric field due to positive will be in this side, electric field due to negative will be in this side, right? So that is very, very important to remember. Now they can cancel each other, so electric field has to be in the opposite direction so that you find that electric field is 0. For 0 electric fields due to individual charges has to be in the opposite direction. They can never be in the same direction. If they are in the same direction, they adds up. If they are in the opposite direction, they cancels each other, right? So in this case, suppose the distance is x and this is the point where the electric field is 0. Now what is the electric field due to A at this point? So this is 1 meter. So the distance from A is 1 plus x meter, and distance from B is itself is x meter. So electric field due to point A is kq by r square. So here k is 9 into 10 to the power of 9. So electric field formula you have to remember, it is always kq by r square, right? Based on case to case we will use the values, right? So here EA is 9 into 10 to the, or rather we will not write it, we will solve it a little bit simpler way. So as we know that electric field due to A is in this direction, electric field due to B is in this direction. So electric field due to A and B must be equal and opposite, so we will use that knowledge. Okay, we will use that knowledge because 9 into 10 to the power of 9 is a common constant, so it will cancel. So here it will be kq1 by r1 square, here it will be kq2 by r2 square. So kk cancels. That's why we will not multiply, we will just simply try to solve it like this. So what is q1? q1 is 4 microcoulomb. Micro means 10 to the power of -6. r1 is 1 plus x whole square, and here it is q2 is -1, so we do not consider sign while calculating electric fields. Remember that even though it's a vector quantity, we only consider the direction due to the fields. We do not consider the sign of the charges. So I repeat it once more. I have repeated that in my class as well. Whenever you are considering electric field, you should not consider the sign of the charges, only the direction is important. Okay, so q2 is 1, r2 is x. Right, now 1 microcoulomb means 10 to the power of -6. So 10 to the power of -6, 10 to the power of -6 cancels. Now we will do the cross multiplication. 4x square equals to 1 plus x whole square. Now it's a very simple easy equation. 2x whole square equals to 1 plus x whole square, or 2x equal to 1 plus x, or 2x minus x equals to 1, or x equals to 1 meter. So the correct answer for this question is 1 meter. Okay, so not an easy question, not a difficult question either, but you have to know that for two charges of opposite sign, the neutral point or null point where electric field is 0, you will be located outside. Now because -1 is given, we are using this side. If +4 is given, we might use the other side as well. So you can try to find the electric field null point on this side. If it is coming in negative, that means in the opposite side. Okay, try to find that. Now question number 2. Hi, good evening, Sushant Chinta. Hello. If the charge on the body is 1 plus 1 nanocoulomb, then how many electrons are removed from the body? So this is a easy question. If you remember my class, there I have told you, if the charge is given 1, 2, 3, 4, 5, 6, 7, 8, then there is a shortcut formula. If it is given 1.6, 3.2, 4.8, 6.4, that is the multiplication of 1.6, then there is another formula. Okay, both are shortcut formulas, both formulas you need to remember. Right, so if 1 nanocoulomb charges are removed, then the number of charge is very simple, 6.25 into 10 to the power of 18 into the charge. This is the formula. If 1, 2, 3, 4, 5, 6, anything other than direct multiplier of 1.6 is given, use this formula. If 1.6 multiplication is given, then the formula is simple, n is equal to charge 1 divided by the charge. Okay, sorry, charge divided by the electrons charge. Okay, so Q divided by E. So this formula is applicable when the charge is 1.6 coulomb or 3.2 microcoulomb or 6.4 nanocoulomb. So in those cases you can use this formula directly. Otherwise, this is the direct formula. This saves some time for you, right? So 1 nanocoulomb you have to multiply 6.25 into 10 to the power of 18 into 1 into 10 to the power of minus 9. Nanocoulomb means minus 9. So it will be 6.25 into 10 to the power of 9. So this is the shortcut formula that you must remember to solve questions. Okay, in KCET exam, this kind of question as well as this kind of question, both kind of questions came. You for this kind of question, this is the shortcut method. For this kind of method, this is the shortcut method. But you can obviously use both methods for both the problems, but it will take extra time. Here also it will take extra time. So avoid that, solve it using shortcut for respective questions. Easy shortcuts, so no difficulty in remembering. You can note it down in your notebooks. Two small spheres, each having charge plus Q, are suspended by insulating threads of length L from a hook. This arrangement is taken in space where there is no gravitational effect. Then the angle between the two suspensions of the tension of each wire will be. So here we have two charges. Okay, both are plus Q. Okay, and they are suspended like this. Now in when they are in earth, okay, some gravitational force is acting downward, okay, and there are some repulsive force which is acting sideways. So that's why it makes a shape like this. But when you take it in the space, there is no gravitational force to balance them. So in space, only one thing that can happen is that Q on this side, Q on other side. Okay, they are suspended by threads of length L. So this length is L, this length is also L. So the angle between them in space will be definitely 180 degrees. Okay, so when they are taken in space, obviously no force is there to balance downward force. That means they will, the repulsive force, the Coulomb repulsive force will dominate and they will repel each other, and the angle between them will be 180 degree. There is no other angle possible. Okay, that is first thing. Second thing is that what will be the force? Very easy. So you have to apply Coulomb's law. Only thing you have to consider is the distance between the charges is L plus L, that is 2L. So the distance between the charges is 2L. So now use the Coulomb's formula, that is 1 by 4 pi epsilon naught Q into Q, Q into Q divided by 2L whole square. This, and the same force will be acting as the tension of the wire. Right? Tension should balance it, otherwise the wire could break. So because the wire is not breaking, that means tension is balancing that. So that means the force will be 1 by 4 pi epsilon naught Q square by 4L square. So the tension will be 1 by 4 pi epsilon naught Q square by 2L whole square. Angle is 180 degrees. So if you only go by the angle, two of the answers can be correct, either this one or that one. Now if you see, this one is more correct, this one is wrong, because the distance will be 2L, not L, right? Easy. Now let's move on. If you want to solve more such questions, and if you want to build a more conceptual understanding of each and every topic, if you want to master everything, and if you want to practice this kind of questions and more shortcuts, then definitely you should join our Pariksha Veera batch. The batch is going to start from 6th of July, and if you are really have not yet joined, don't forget to join it. The link of this is given in the description section of this video, so you can close the live chat right now and you can join in the batch, right? More details about the batch is discussed in separate videos, and I will discuss a little bit more at the end of this lecture. A charge Q is placed at each opposite corners of a square A. A charge small q is placed of the other two corners. If the net electrical force on capital Q is 0, then Q by small q is. So let me draw a square. So suppose this is a square, right? So now what is said, capital Q is placed on these two corners, and small q are placed in the opposite corners, right? So this is the information given in this question. Also it is given that the net force on any one q you can take, say we are taking this charge, okay, net force acting on this capital Q is 0. Okay, and then what will be the ratio of capital Q divided by small q, right? So let's figure out, if all the charges are positive, what force would have been acting on this. So if obviously if we cannot find any equilibrium, then one of them can be negative. So first, these two charges are obviously of same sign, that is mentioned in the question. So the force acting on this must be, force acting on them must be repulsive. So if you join these two charges and extend it, okay, so this must be positive. So this is the direction of force due to this. So this is FQ, right? Now what about this? So if this is repulsive, if both of them are positive, okay, then it should be a repulsive force. Sorry, this should be a repulsive force. So repulsive force means in this direction 1, okay, in this direction 1, and 1 is another this direction. But in that case, if you see their addition, they will be adding up, and the force, awayward force will be increased, because if you draw two arrows like this, one arrow like this, one arrow like this, okay, then their resultant force will be along this direction, right? So basically what happens is that if both of them are getting added, that means their resultant is in the same direction as the original repulsive force, so it will not be able to achieve a equilibrium position or a zero force. That means the assumption that both charges are positive is wrong. Okay, so the charges must be negative, one of both charges must be negative, and that means the resultant due to Q is in this direction, and small q, just a second, and small q must be in this direction. That means their resultant is now acting in the opposite direction of the force, must be acting in the opposite direction of the force, that is in this direction. So they will cancel each other, right? I hope the diagram is clear now. Now let's go back. So that means these charges must be negative, but that ratio must be negative. That means either one of them will be correct, either this one or this one is correct. One more is there, this can also be correct. So these three must be, one of them will be correct. Now let's find out what is the correct ratio. Suppose the side is A, okay, then what is the diagonal of a square? It will be root 3 by 2 into A, right? For a diagonal, no, sorry, diagonal of a square will be root 2 into a. Okay, diagonal of a square is root 2 by a, root 2 into a, right? So now, so this is the diagonal of the square. This is the force. So what is the force? F capital Q. F capital Q must be equals to K Q into Q by root 2a whole square. This is the capital Q force. Okay. What about this force? F small q's. Obviously these two forces will be equal. They are equidistant from the charge. So F small q's should be K capital Q into small q divided by a whole square. Right? Now these two are acting at right angles. This angle is 90 degrees. So what is the resultant? This resultant, say FQR. So FQR, the resultant force will be, take this force, multiply it with root 2. So when two equal and opposite, two equal forces are acting at right angles, their resultant is FQ into root 2. These things you have studied in your Q1. If you have not studied, you need to go back and revise them once more. So FQR will be equals to FQ into root 2, right? So now we have to use these values in this equation. So it will be K capital Q small q divided by a square into root 2. Now as it is mentioned that the net force acting on this is 0, that means they are equal and opposite. That means this FQ, F capital Q must be equals to F small q r, right? This resultant force must be equal to this, and they are opposite in direction. So sign will be negative. So whatever we calculate, the final answer will be negative. You may not get that from this calculation obviously, but we will write the answer as negative. So a square into root 2 equals to K capital Q by root 2a whole square. Right, one of the capital Q's cancelled, K cancelled. Now we are left with root 2q by a square equals to q by 2a square. Now a square cancels, and you get capital Q by small q equals to 2 root 2. Now as I mentioned, the answer will be negative. So correct answer is option A for this question. Right, very interesting question. And important question, very conceptual. If you are practicing enough question, this kind of question should be your bread and butter, right? You have to practice lot of questions. That's why we are bringing this quiz session with all of you. Two charges 4q and q are 3x apart in air. A charge capital Q is placed at a point on the line joining so that the system of these three charges remains in equilibrium. Then the distance of capital Q from 4Q and the value of capital Q are. So two charges 4Q and Q are 3x apart in air. So again, let me use the tools. Okay, we have 4q and q, the distance between them is 3x. Okay, a charge capital Q placed at a point on the line joining so that the system of these three charges remains in equilibrium. Somewhere here we placed a third charge capital Q. Okay, the system remains in equilibrium. Okay, then the distance of capital Q from 4q. So what is the distance between them? Okay, so say this distance is y. Okay, so what is the value of y and the value of q? What is the distance y and what is the value q? So these two we have to find out from this information. Now system is in equilibrium means net force acting each and every charge is 0. Net force acting each and every charge is 0. Now for this kind of question, we need to consider equilibrium of any one of the charge which is at the edge, either this one or that one, both fine, and we also have to calculate the net force acting on the central charge. If the central charge is, if both these charges are equal and central charge is placed at the middle, then only one edge charge is sufficient. But here, because charges are unequal, the central charge, the charge is not placed exactly at the midpoint, so we have to find the equilibrium of this charge as well. Let's see. So first we will consider the equilibrium of the charge 4q. So equilibrium of this charge 4q, what are the forces acting on it? So there is a repulsive force due to this q in this direction, and that means this capital Q must be negative, and this should attract the object in the opposite direction, right? So now we will apply that. So what is the force due to small q charge? Force due to small q charge is K 4q into capital Q, 4q into q divided by 3x whole square. Coulomb's law. Basically all the questions here up to this point mostly based on Coulomb's law or electric field. Okay, now we will consider the equilibrium of this capital Q charge. We will consider the force due to capital Q charge. Force due to capital Q charge is given by K 4q into capital Q divided by y whole square. Now as the system is in equilibrium, that means we can say that force due to small q plus force due to capital Q must be equals to 0. So the net force acting on the system is 0. So now we will put this back to back. So 4q into q divided by 3x whole square plus 4q into q by y square equals to 0. Now what we have done here, we have basically added these two forces. K was common, so you can take K common and you can cancel it, right? Now we have to simplify it. Obviously 4q is also common, you can cancel that as well. So what we are left with, q upon 9x square equals to minus capital Q upon y square. Okay, so from this you can calculate the value of y square. So y square equals to minus q into 9x square by small q. Okay, so this is the ratio, this is the distance between these two charges. Obviously it is not done yet. We have to consider the equilibrium of the central charge as well. So for that, let me add a page. I don't know what is happening. Let me change the color. Okay, now we are fine. So basically we had these charges 4q, capital Q and small q. This distance was y, this was 3x. So this equilibrium is done. Now we are trying to find the equilibrium for this one. So what are all the forces acting on this? So there will be one force due to 4q, one force due to small q. So force due to 4q, force, we are considering the equilibrium of capital Q. So force due to 4q is given by K 4q into q by y square, and force due to small q is K small q into capital Q divided by 3x minus y whole square. So total distance was 3x, this was y, that means this much distance must be 3x minus y. Okay, now we will compare these two values. Obviously because the system is in equilibrium, so 4q plus fq must be equals to 0. Put that value here. K will common and cancel. Small q will also be common and cancel. So 4 capital Q by y square equals to minus capital Q by 3x minus y whole square. Obviously, capital Q will also cancel. Now we cross multiply. 4 into 3x minus y whole square equals to y square. Right? Now we will take square root on both sides. We get 2 into 3x minus y equals to y, or 6x minus 2y equals to y, or 6x equals to 6x equals to 3y, or y equals to 2x. Now here I don't think you need to take the negative sign, because these forces are already in the opposite direction, so it will be minus here. Okay, so y value is 2x, we have calculated. Now we go back to our previous page and we have to put that value. So y value is 2x whole square equals to minus q into 9x square by q. So from here we can calculate the value of q, which will be minus 4x square into q by 9x square. X square cancels, and we get minus 4q by 9. Minus 4q by 9. So minus 4q by 9 and 2x is the distance. So correct answer is option B. Right, again a difficult question, not very easy, but you have to practice these kind of questions step by step, so that you master this kind of questions. Okay, so these kind of questions are not easy to solve without practice. Right, next question. 2-point charges are 3 meter apart and their sum is 8 microcoulomb. The force of repulsion between them is 0.12 Newton. Charges are, so here this is a easy question. You don't need to do any mathematics, you can solve it easily. Just read the question properly. So two charges are here, one is 8 microcoulomb. Okay, distance between them is 3 meter. Okay, the force between them is 0.012 Newton. Right, so first thing you have to do, you have to write obviously Coulomb's law, that is K Q1 Q2 by R square. Okay, your only job is to find the value of Q1 Q2. This problem is easy. If you see similar question in the exam and do not apply that, okay, the multiplication of the charges must be 12, do not apply that, because they might lay some trap. So first step obviously you have to do, write down Coulomb's law, find the value of Q1 Q2. That it will be taking only 5 to 10 seconds. As soon as you done that, your problem is solved. Okay, so F is given 0.012, K is 9 into 10 to the power of 9, Q1 Q2 is not known. Okay, Q1 plus Q2 is known, but Q1 Q2 is not known. R square here is given 3 meters, so 3 square is 9. Okay, R given here as 3 meter. That means R square is 9, so 9 cancels. So you get Q1 Q2 equals to 0.012 into 10 to the power of minus 9, or 12 into 10 to the power of minus 12. Okay, so 12 into 10 to the power of minus 12. Now you are sure that, okay, if I multiply two charges, it must give me 12. Okay, microcoulomb, obviously 10 to the power of minus 12 represents microcoulomb. So 10 to the power of minus 12, basically if you divide this 12 by 2, whatever value you get, that is the magnitude of the charge. So that is 10 to the power of minus 6 is the magnitude of the charge. Okay, so it will be in microcoulomb, and the multiplication of the two charges should give you 12, addition of them should give you 8. Now, is there any combination which is giving you both? So 4 into 4 is 16, 5 into 3 is 15, 7 into 1 is 7, but 6 into 2 is 12. So that means your answer is 6 and 2. So if you add these two, you are getting 8. If you see, all of them can be added and give you 8. But only one will give you the multiplicative value, that is 12 as well. So first simplify, find the value of Q1, Q2. Don't be in a hurry. Seeing this 12, do not go, because if the distance is not 3 meter, if it is something else, then this value will not be 12, it will be something else as well. So make sure you follow the step, find the value of Q1, Q2, and then you apply the logic that the multiplicative value of the two charges should give you 12. Now you check that the addition should give you 8. So addition wise all the combination is correct, but multiplication wise only one combination is correct. So then you choose the correct answer. So that is very, very important, right? Now let's move on. 2 point charges, 2 coulomb and 6 coulomb plus 6 coulomb repel each other with the force of 12 Newton. If a charge of minus 2 coulomb is given to each of these charges, what will be the force now? So 2 point charges, 2 coulomb and 6 coulomb are repel each other with the force of 12 Newton. Now you have given minus 2 coulomb to each of them. So if you see that minus 2 coulomb, when you given it to plus 2 coulomb, what will be the net charge? So Q1 initially was 2 coulomb. What will be the Q1 dash when you add minus 2 coulomb to that? So charges are additive in nature, so you have to use the sign of the charge, right? So it will be 0 coulomb. So if one charge becomes 0, then from Coulomb's law, force is proportional to multiplication of the charges. So if one of them is 0, the force will obviously be 0. No need to calculate, you just add them in your head. See that the addition gives you 0. That means net force will also be 0. No need to solve it, obviously, right? So easy question. So these are the KCET easy level questions where you don't need to solve anything. If you do the simple mathematics in your head, you should be able to solve it. There are some questions where you need to do a lot of calculations. There are some questions you need to do small calculations, for example the previous one, and in some cases you do not need to do any calculation, only small analysis should help you, right? Now let's move on. An electron of mass m, charge E, falls through a distance h meter in uniform electric field E. Then the time of fall is. So if you see that mass of the charge is m, mass of the electron is m, charge is given by E, okay, and it falls a distance h meter in a uniform electric field E. Then what is the time of fall? Completely different question. You might think, oh, what to do? Mass is given, charge is given, height is given, electric field is given, but they are asking about time. So do not be confused. Basically it's a somewhat mixture of your P1 and P2 concepts. So we know that whenever you keep a charge in the electric field, what is the force acting on that charge? Force acting on that charge is Q into E. And whenever there is a force, father is always accompanied by mother. So father equals to ma. Okay. So from there you can calculate the acceleration. Acceleration of the charge will be given by Q into E. Q into E by m. So acceleration is calculated. Now the distance traveled is given. So we know that S equals to ut plus half at square. So using this equation we can easily calculate the time. So for this question, S is given as h. Initially it was starting to fall from the rest, that means u is 0. So now you put that value, obviously q itself is given as E. So now you have to put those values and calculate the value of time. So h equals to half at square. So t equals to basically 2h by a square root, right? Now we have to put the value of acceleration only, then our job will be done. So what is the acceleration? If you see here, acceleration is E small e capital E divided by m, right? Small e capital E divided by m. So m will go up and you will get 2h m by E into E. Very easy. 2 by E into E. Option A is correct. Okay, so don't be confused. These kind of questions are common in KCET, and they try to confuse you by us giving you a simple question. So only thing that you have to understand that force due to electric field on the charged particle, then Newton's second law of motion, calculate acceleration, and then you use the equation of motion. That's it. Right? Two spheres carrying charges plus 6 microcoulomb and plus 9 microcoulomb separated by a distance d experiences a force of repulsion F. When a charge of minus 3 microcoulomb is given to both the spheres and kept at the same distance as before, the new force of repulsion is. So here we have initially 9 microcoulomb and 6 microcoulomb. Okay, so what is the initial force? Initial force was proportional to Q1, Q2. That is proportional to 6 into 9, that is 54, right? So this was the initial force. Okay, some proportionality constant is there, K Q by R square, obviously K and R are being constant, so there will be some proportionality constant, but initially the force can be written as a constant into 54. Now what happens, you add minus 3 microcoulomb to both the charges. Now you see that none of the charge becomes 0, so force is not 0 anymore. Okay, so minus 3 you add to this, minus 3 you add to this. Even though they reduced, their magnitude does not become 0, so force is not 0. Now what will be the new force? New force will be 6 minus 3 is 3, obviously a constant, into 3. 9 minus 3 is 6, so that will be C into 18. Okay, so this is the new force. Now if you see that, what will be the new, if you consider that, it will be C into 54 by 3. Okay, 3 ones are 3, yes. So this will be basically F by 3. So the new force is basically F by 3. Okay, and you can guess, if you want to guess, that 3 is given in both options, so one of them must be correct, either 3F or F by 3. So generally they repeat the option for correct answer, right? So this is also very, very important point to note. Let's move on. A spherical conductor of radius 2 centimeter is uniformly charged with 3 nanocoulomb. Spherical conductor, radius 2 centimeter, is uniformly charged with 3 nanocoulomb. What is the electric field at a distance 3 centimeter from the center of the sphere? So here we have a spherical conductor and we are trying to find the electric field outside the sphere. So this is the application of Gauss's law. So 2 centimeter is the radius, 3 centimeter is the distance. Charge given here is 3 nanocoulomb. Now as you know that for distances smaller than the radius, electric field is 0. Distances greater than the radius, we can simply use the normal equation of electric field, KQ by R square. So 9 into 10 to the power of 9 into 3 into 10 to the power of minus 9 divided by 3 centimeter. Now whenever there is a centimeter, always convert into meter by multiplying 10 to the power of minus 2. Do not go for decimals, point, etc. That creates confusion. Okay, so 10 to the power of 9, 10 to the power of minus 9 cancels. We get 9 into 3 divided by 9 into 10 to the power of minus 4. 9 cancels. You get 3 into 10 to the power of 4. So the electric field is 3 into 10 to the power of 4 Newton per coulomb or volt per meter. Both are the units of electric field, right? Now let's move on with a few more questions. Some of the questions might be familiar. the number of electrons in 1 coulomb charge. So as I mentioned that if the charge is given as 1 coulomb, 1 nanocoulomb, 5 coulomb, 10 coulomb, in that case it is very easy that you can find the number of charge to be 6.25 into 10 to the power of 18 into the charge, right? So if you see here the charge is 1 coulomb, that means simply 6.25 into 10 to the power of 18. So this is the number of charges. Okay, no other calculation required. Easy question, easy answer. An electric dipole consists of two opposite charges, each magnitude 1 microcoulomb, separated by a distance of 2 centimeter. The dipole is placed in an external field of 10 to the power of 5 Newton per coulomb. The maximum torque on the dipole is. So what is the value of maximum torque? Torque equals to P E sin theta, right? This is the formula for torque. Now torque will be maximum when sin theta is 1, right? Torque will be maximum when sin theta is 1, that is the angle between them is 90 degrees. So now let's put the value of P. Now what is P? Dipole moment. Dipole moment is charge into the distance between the dipole. Okay, normally we write Q into 2A, but here 2A itself is the distance. Some student confuse with this and put 2 in the equation, because here the distance between them directly is given 2 centimeter. So they will add one more 2 into this equation and they create this problem wrong. They solve this problem wrong, get 0 marks, right? So that is important. Do not confuse. You should remember that the dipole moment is charge times the distance between them. Charge times the distance between them. So what is the charge? Charge is 1 microcoulomb. Micro means 10 to the power of minus 6. Distance between them is given here 2 centimeters. So as I mentioned, 2 centimeter, always convert it into meters. So you get this as 2 into 10 to the power of minus 8, right? 2 into 10 to the power of minus 8 is the dipole moment. So 2 into 10 to the power of minus 8, and electric field here is given as 10 to the power of 5 Newton per coulomb. Right? Now multiply, you will get 2 into 10 to the power of minus 3. So this is the torque. Maximum torque is 2 into 10 to the power of 3. Now be careful, if the question answer is given 0.2 into 10 to the power of minus 4, they tried to give it here, but that is wrong. So they might give you 20 into 10 to the power of minus 4 or 0.2 into 10 to the power of minus 2. So be careful about those values. There are tendencies that some cases they will not give you the direct value. They will try to confuse you a little bit, right? Two small charged spheres A and B have charges 10 microcoulomb and 40 microcoulomb respectively, and they are held at a separation of 90 centimeter from each other. At what distance from A the electric field intensity would be 0, right? So here we have two charges. Don't worry about the numbers, actually it is question number 13. I could not number it because I was little occupied today. So 10 microcoulomb and 40 microcoulomb, the distance between them is 90 centimeter. Okay, so distance between them is 90 centimeter, 10 microcoulomb and 40 microcoulomb, and both of them are positive charges. So as I mentioned, if the charge, both charges have same polarity, then the null point or the zero electric field point happens between the charges, and it happens closer to the smaller charge. It happens between the charges and it happens near the closer charge. Suppose this distance is x. This distance is 90 minus x. Okay, so k q1 by x square equals to k q2 by r minus x whole square, right? So from here basically you can calculate the value. So r minus x by x whole square equals to q2 by q1 okay, or if you take the square root of both sides, r minus x by x equal to square root of q2 by q1, bigger charge by smaller charge. If you remember this formula, then you might save some time in the exam. So this is the formula to calculate null point when you are calculating between. If it is outside, it is simply you have to put a plus sign, that's it. Okay, so r minus x are given here as 90 centimeter, and for your reference you do not need to add 10 to the power of minus 2, minus 4 because all the units here is 90 centimeter. Answer is also given in centimeter, so you don't need to change the unit as well. That is also very, very important. So now we will use the formula. R is 90, x we don't know, divided by x equals to square root of q1. Q1 is Q2 is 40, Q1 is 10, so square root of that is 2. Now do the cross multiplication. 90 minus x equals to 2x, or 90 equals to 3x, or x equals to 30 centimeter. So the distance from the smaller charge, distance from the 10 microcoulomb charge is 30 centimeter, and in the question also they have asked the distance from A, that is small charge. Remember that for this kind of cases, distance will be shorter for small charge, distance will be longer for the bigger charge. Obviously bigger charge will have bigger influence, so it can create the null point far away from it. Okay, so correct answer here is 30 centimeter. Fortunately 60 centimeter is not given as option. A charge Q is placed at the center of a cube. The electric flux passing through the cube is. So here we have a cube, not a square but a cube. Cube means it's a 3 dimension, right? Right, so it's a cube. So if you see here, so a charge is placed at the center. What will be the electric flux? Very simple, Coulomb's Gauss's law. The flux is basically independent of shape of the object. It is basically, because it is at the center, it must be Q by epsilon naught. Nothing else. It can be sphere, it can be cube. Okay, electric flux will always be Q by epsilon naught because charge is at the center. If it is at the corner, then you need to construct something with which you can cover the charge completely, count the number of cubes, divide it, get the value. But here it is at the center, so no need to worry. In KCET, corner, this year I think they have given at the edge. So you need to cover the cube equally, symmetrically, so that you make a symmetric structure and then you calculate the electric flux through that. Okay, so it will be Q by epsilon naught. An electric dipole placed in a non-uniform electric field experiences, so if the electric field is non-uniform, it experiences both force and torque. I explained this in my theory lecture. If the electric field is non-uniform, it experiences both force and the torque. If the electric field is uniform, it experiences only torque. So dipole will always experience torque in external electric field. If it is uniform, only torque will be there. If it is non-uniform, then torque and force both will be there. Let's see how many questions we can solve. A charge small q is placed at the center of the line joining two equal charges, capital Q. The system of the three charges will be in equilibrium is if small q is equal to. So the problem that I was discussing about, so this is that problem. So let's see, here we have the charges are equal here, so both charges are capital Q, and at the center, exactly at the center, we have placed a small charge Q. Now system is in equilibrium. In this case, you can only consider any one of the edge charges. No need to consider the central charge, that is in equilibrium by default. Okay, so that is very, very important. Suppose the distance from this is x, this is x, so total distance between them is 2x. Okay, now we will consider equilibrium of this charge. So because both of the charges are same, equal in magnitude, that means they will be positive, or if they are both can be negative as well. So the repulsive force must be away from To balance it, this force must attract this towards them, right? So this force must attract them toward them. Now if this force, say capital Q, this force is small q, okay, so we can write that F capital Q plus F small q must be equals to 0, because obviously the system is in equilibrium. So what is F capital Q? F capital Q is K Q into Q by 2x whole square, right? K Q1 Q2 by R square. So R for both the capital Q is 2x, that's why 2x, plus K capital Q into small q divided by x square equals to 0, right? So this is due to small q, distance is x, q into small q divided by x square. Obviously k and one of the q will be cancelled, so you can cancel that. Common, basically that will be common and that will be 0. So q by 4x square equals plus q by x square, that is equals to 0. So q by 4x square equals to minus q by x square, or small q, x square cancel, small q equals to minus q by 4. The charge should be minus q by 4. So correct answer is option A. One more question. 2 points Q1 equals to 2 microcoulomb, Q2 equals to 1 microcoulomb are placed as shown. So this one and this one are placed as shown. Okay, one is 2 microcoulomb, one is 1 microcoulomb. The coordinates of the point P are 2 centimeter and 1 centimeter. The electric intensity vector at point P subtended an angle theta with the positive x-axis. The value of theta is given by. So basically, don't worry about this question. Okay, so what they have said that this point, the coordinate of this point is 2, 1. Okay, this charge is 2 microcoulomb, this charge is 1 microcoulomb. Okay, this distance, x distance is 2, so this is 2, y distance is 1, so this is 1. Now they are asking you, if you try to find the resultant electric field, okay, if you calculate the electric field due to Q1, electric field due to Q2, okay, and this electric field, the resultant electric field, what angle it makes with this? Basically this is the question. So this is EQ1, this is EQ2. Okay, so this is y-axis, this is x-axis, and we know that the slope of the line tan theta is given by y upon x. The slope is given by y upon x, that means it will be EQ2 by EQ1. Okay, what is EQ2? EQ2 is KQ1 Q2 by KQ1 by R square. So K into Q2 is 1. Okay, divided by R square is also 1. Now we are not using any units because all of them have same units, so units will automatically cancel, and we are trying to find a ratio, so no need to worry. The microcoulomb, centimeters will be cancelled for this particular question, right? So you have to be smart, do not waste too much time on conversion. Okay, so K into 1 divided by 1 square. Okay, that is Q2. Now what about Q1? Q1 is K into 2 divided by 2 square. Okay, K Q1 by R square, right? So obviously K cancels and you get 1 divided by 2 by 4. That is 4 by 2, that is 2. So tan theta equals to 2 is the correct answer for this question. Sorry, I could not complete the class in time. The time is over. Now, obviously, if you want to join our Pariksha Veera to practice more such questions with us during the lecture, then definitely you should join our Pariksha Veera batch, which will going to start from 6th of July. Full PU2 syllabus and KCET readiness, and you will get 110 plus hours of class per subject: physics, chemistry, maths, and biology. 20 plus tests per subject, part plus full length. Okay, each subject will have 20 plus tests. Part test means whatever syllabus is being completed throughout the series, you will be tested based on that, weekly test, monthly test, etc. And full length test is when entire syllabus is completed, you will be given full length test as well. Now also during the lectures you will get teacher notes, assignments, unlimited DPP generator, so you can practice more questions, you can generate your own DPP, you can solve them, check the answers, etc. And the entire lecture will be delivered in the Wave app of Vedantu, and entire series will be live classes. It will consist of live classes, and if you want to know more about the detailed views, obviously we have done 2 lives, one on this Monday, one yesterday. You can go and check that out about if you want more clarification regarding the batch, right? So this is the end of today's session. If you have any questions, any doubts, please mention that in the comment section below. I will try to address them as soon as possible. The lecture notes, PDFs, etc. will be available in our WhatsApp channel as well as in the description section of this video. Do check that out later on, right? All the best for your KCET 2027 preparation. I'll be back. Till then, bye.